Now, we looked at just one decision variable, that is how many seats to set aside for Y class in the previous example. Of course, in real world situation, there will be a lot more complexity in the problem. So there will be a network of routes to consider, many of them, hundreds if not thousands. Uh, More than two fare classes. We looked at only Q and Y class. There may be 10 or 15 different fare classes. Okay, different price breaks for, we may want to consider different price breaks between fare classes, not just one. So how about instead of 100 and 300, how about 150 and 350 and so on. So there are the number of decision variables can very easily add up, and we're going to take a look at that now. All right. So here, so what effect does price have on demand? That's another thing. So if you increase the price for Y class beyond a certain limit, then the Y class passengers will probably opt to travel in Q class. Um, so the demand may shift based on the price. So so far in the previous instances of this example, we did not consider the price and the demand. Demand was just normal, mean, standard deviation, and price was kept separate. So now we're going to combine the two. So effect of price on demand. So Q class, every $10 increase will decrease the demand by $9 on average. Okay, starting from 200. So if we're going to put a floor, so 200 minus, so 9 over 10 per dollar, so 0.9 times Q price. So Q price goes up by $1, then the demand will go down by 0.9. So that's for Q class. And we'll assume the standard deviation is going to be that. Okay. Now Y class, a $10 increase will decrease the demand by 1. So obviously, the higher price, it will be less affected by the increase in price. So starting from 60, so it will start declining. So for $1, 0.1. So 0.1 times Y price, and the standard deviation is the same. Okay, and then in this case, then there is one more thing to consider, and that is the prices. Well, how many seats to reserve? That's your decision variable, and the prices for Q and Y. When you generate the prices here, we need to make sure that the prices cannot be negative. Okay, and Q class price must be less than or equal to 222. If you calculate it through, you'll see that the demand will end up being negative. Okay, the mean demand will be negative. And similarly here, if it is less than 600, then you end up being the mean being negative. So mean itself is negative, then half the demand that we generate using normal distribution will be negative. So it will be useless. So we will impose these two constraints besides the price being non-negative. Okay, and the other model-based constraints are already set up in the Excel model, as we saw before. And the objective is revenue maximization. Okay, and we will set up this model, and then we look at the strategy for efficient solving. Okay, let's head on over to Excel. So we already have the model that we worked on before, right? So that model is here. Now, what we have in addition to what we had previously is the mean. So Q demand, the mean demand is going to be for Q is 200 is the intercept B sub 0, and minus 0.9 is the slope. And for Q class, I'm sorry, Y class, it'll be 60 and minus 0.1. Okay. So those are the parameters for generating mean demand, that and that. Okay. And for standard deviation, it is 7 and 0.01. Okay. And okay. Now we're going to generate the mean standard deviation from this. So whatever price, okay, so we're going to um, come up with, so this is going to be our decision variable. So let's change the border background color. So we're going to set this up as decision variable when we get to risk optimizer. Okay. Now these will be calculated cells. So no background color. So the mean will be B sub 0. Okay, it's kind of backward here. So B sub 0 plus B sub 1 times the price. Okay. Now here B sub 0 plus B sub 1 times its price. Okay. The standard deviation is that. Okay, I'm going to make that absolute reference because there is only one equation for both. F4 again multiplied by the price. Okay, and we copy that. All right, so these are demand. So I don't want currency. So we'll just number on decimal places. So those will be the means based on which the demand will be simulated. Okay. Now that would be a decision variable as well, and we are still going to consider between 25 and 50, and this is our output cell. Okay, so the model is ready. Now here as we change the price in optimize, okay, the changed price will run through these coefficients, and the mean for demand and standard deviation for demand will change.